Hello, welcome to another productivity webcast brought to you by Digital Dimensions, Ford Engineering Solutions. Today we're going to talk about SOLIDWORKS weldment tips and tricks. I'll be your host, Joseph Richter. First off, I'll introduce you to the weldment environment and the changes that it makes to the part. Then I'll demonstrate and explain structural members. Utilizing these structural members, we'll talk about trimming and extending them so they butt up correctly to one another. Then we'll talk about adding additional structural member profiles to the default library. I'll show you how to generate fillet weld beads. We'll talk about dealing with non-structural member components, things like off-the-shelf parts or custom parts that you may build, or maybe even additional plates that you want to add to your weldment. I'll show you how to add end caps and gussets. We'll talk a little bit about sub-weldment and post-machining operations. Sub-weldments are like sub-assemblies. You weld them up first before adding them to your top-level weldment. We'll talk about the cut list, and here's one of the tips, an exploded weldment. Then we'll finish up on Weldment Drawings. First up, we'll talk about the weldment feature. When you select on the weldment feature, it makes a few changes to your part file. First off, the solid bodies folder becomes the cut list folder. It generates the following configurations: the as machined configuration to represent post-machining operations, and an as welded configuration, which is a child configuration of the as machined configuration. The parent-child relationship here means anything that we do to the top level or the parent configuration filters down to the child. In this case, however, our as machined version of the part will have the most mature features. The as welded, the child, the derived configuration, will be able to suppress features that we do not want going through to the weldment. The other thing that happens to your part file is any subsequent features that you add that take advantage of the merge results option, this will now be unchecked. That way the volumes are not added together. A weldment tip. I want you to remember that the weldment functionality is basically an automated sweep tool. Therefore, it is not reserved for just steel structures. If you have a product that could take advantage of the cut list functionality offered in the weldment feature, then I invite you to watch this webcast with an open mind, and maybe I can show you how to apply this feature to your modular designs. Structural members. This is the primary feature utilized in the weldment environment. The default structural members that we have available are square tubes, rectangular tubes, pipes, angle irons, C-channels, and S-sections. When generating a weldment, the first thing that we need to do is generate 2D or 3D sketches to represent our weldment structure. This sketch should represent either the inside corner, the outside corner, or the center of our weldment structure. 2D or 3D sketches can be used, but when planning this out, you should balance the ease of sketching versus the benefit of having all of your paths in one sketch. Now in SOLIDWORKS 2009, they introduced grouping within the structural member feature. This enables me to break the problem of SOLIDWORKS 2008 and prior of having to have multiple structural member features just because my path segments were either not contiguous or not parallel. Now in SOLIDWORKS 2009, I can basically generate different groups within the same structural member feature so long as all of the cross sections of my structural members are the same. The advantage of doing this is as it relates to the structural members butting up to one another. If they're all in the same structural member feature, then SOLIDWORKS will automatically apply corner treatments either globally or individually. So as I show corner treatments here, specify how the structural members will butt up to one another. Again, if they're all in the same structural member feature, then it will automatically give you either a global setting for all those corner treatments, or you can adjust each one individually. And finally, for my structural members, I can specify the location of the initial profile. We can position the initial profile relative to the path based on a pierce point. The pierce point is basically the location of the profile relative to the path. And I'm using this term path as it relates to a sweep feature. Your path would be the trail that your profile follows. And with this, we'll go into SOLIDWORKS. Okay, as I go to add my structural member, I'm going to choose ANSI inch. I'm going to choose a square tube, and I'm going to pick 2 by 2 by 1/4 inch wall. Now I'm just going to run around and click on my path sketch, and as I click on each path segment, you'll notice that SOLIDWORKS is going to go ahead and populate that path with my profile. Again, I mentioned this is the automated sweep tool, and as I take a look here, you can see that SOLIDWORKS is applying a global corner treatment. Okay, right now it's doing the end miter, and as I zoom in here, you can see the end miter. If I was to apply an end butt 1, it would do this. If I did an end butt 2, it would do that. Now, when making your layout sketch, you need to decide if this sketch represents the inside corner or the outside corner of your weldment structure. If this initial sketch represented the outside corner of my weldment structure, then when locating my profile, I'd want to tell SOLIDWORKS that the pierce point for this profile is the outside corner. And when I do that and zoom out, you can see now, actually, as I zoom from the top, that the outside of my structure members is now right on that path. If, on the other hand, this was the inside corner, then I'd want to locate my profile based on the inside corner. Again, when I view from the top here, I'll be able to see that that path is now set to the inside of my location profile. The other item that we can do relative to locating the profile is giving it an angle. If my tubing was to be rotated at 45 degrees, okay, it would generate a weldment profile structure like that. So as I hit OK, I can show you what this looks like. In addition to global corner treatments, we do have the ability to specify individual corners independently. So if I wanted an end butt 1 there, I could do that and then specify a different corner treatment over here, end butt number 2. And as I hit OK, I can show what that looks like. Now, with the advent of grouping, this allows me to add this path sketch as well. If I click on it right now, you'll notice that SOLIDWORKS is ignoring me. But if I made this as a new group, then it would allow me to select that path segment. On the first group, I'm going to go ahead and take away that angle, make it 0 again, and basically demonstrate the advantage of using these groups. As I look from the top here, we're going to see that these are already trimmed to one another. In fact, it's probably hard to see because the fact that I've located the first group's profile on the inside corner. So let me go ahead and update the initial group location back to the center. Now when I view from the top, we'll be able to take a look at the fact that this structural member here has been trimmed right up against the other structural member by virtue of the fact that they're in the same structural member feature. I'm going to go ahead and zoom out again here. Okay, one of the other things that they did in SOLIDWORKS 2009 is they added the ability to specify weld gaps. Okay, if I wanted to specify a weld gap in this corner, I could specify how large of a weld gap. So as I hit OK on that, you can see that it is now gapped, so I can fill that with weld. Again, the advantage of having these groups, being able to set the corners individually, is it does trim them up against one another. Also, I want to point out that since they are all in the same structural member feature, if I need to adjust the structure as a whole, I can modify the cross section. These are all supposed to be angle irons. I could then specify the size, and it's going to adjust every single path with a new profile. And then once you're satisfied with what you have on there, you just specify OK. Now, I did have a 3D sketch in here, so I'm going to go ahead and show that. And in fact, I want to talk a little bit about 3D sketching tips. Okay, while you're in a 3D sketch and you're drawing a line, you'll notice that I can see the XY triad being displayed. That as it relates to the triad in the lower corner. When I start drawing my line, it's going to be along that plane. in order to switch reference plane, I just hit the tab button on the keyboard, and now my plane reference has been switched to YZ. If I hit tab again, it's going to go to ZX. So again, hitting tab will basically change your direction reference for your lines in a 3D sketch. Now, having said that, the reason I have this 3D sketch here is I did want to point out for structure members as it relates to pipes. When I grab a pipe and I specify a size, and let's say I want to populate this path here. Because this path has arc segments in it, I've got two options. I can either specify this as being one tube that's being bent, or that they are individual structural members. Now, I'm going to go ahead and leave these merged together and hit OK and show you that we have 6 cut list items. If I was going to edit that feature and ask SOLIDWORKS to not merge those segment bodies, what it's going to do is it's going to generate basically 6 different structural members. So now I've got 12 on my cut list. And to kind of show that, I'll go ahead and move with the feature here, move copy, and I'll move that out so you can see that that item is separate. Whereas if it was all merged, the whole thing would move together. Okay, so again, we do have the ability to specify whether or not these arc segments are merged. So if you're bending tubes, you can represent those, or you can represent individual joints. So like if you're soldering stuff together for copper tubing, you can specify those joints in that fashion. And with that, we'll get back into the slideshow. Trim and extend. We can specify how these structural members butt up to one another utilizing the trim and extend function. Now, this will also allow me to generate corners between structural members that were not in the same structural member feature. Another weldment tip I want to talk about here is interferences can be checked between structural members if you drop this into an assembly utilizing the interference detection and the option include multi-body part interferences. Also, the isolate can be utilized at the part level to see the individual structure member pieces. Over here in SOLIDWORKS, I'm going to go ahead and open my next item, and we're going to talk about the trim extend. If I wanted to specify a corner, maybe I want an end miter between these two items. Okay, SOLIDWORKS will go ahead and generate an end miter feature on that. If I wanted to do another trim extend, maybe I want an end butt number 1 between these two. Okay, SOLIDWORKS will overlap it that way. Maybe I want to switch the corner. I can do that. Using trim extend, I'll specify this body to be trimmed, and I want to trim it based on this body here. In fact, I might also want to trim it with this structure member back here. And as I specify OK on that, I can take a look at this individual piece simply by isolating the body. You right click on that structure member, do body isolate, and now I can see this individual piece, and I can see it was coped just fine and cut flush on the backside. Now, one of the things that you'll notice that's different in 09 than it was in 08 is I was using a body trim. Okay, that body trim basically enabled me to do a simple cut. This is something they added in 09. In 08 and prior, it would basically cope between all the bodies. It would act like a combined subtract. Well, now in 09, we recognize that anytime you have a planar face involved, then that structure member might butt up there, should be cut flush. So now we have the ability to specify simple cuts between bodies. If I left it cope between bodies, this is what we would have seen in 08 and prior, and as I isolate that body, you can see what I'm talking about. Okay, so the simple cut option will literally create a simple cut between those structural members. Again, under the trim extend, that was these two options here. One of the other items I want to show is maybe I want a miter in this corner here. So with trim extend, I'll ask for another miter. and that will generate a miter in that corner. And then I want to cope this tube based on those there. So with structural member, I'm going to specify a trim, and bodies to trim is that one, and I want to trim it on these other two bodies. And again, I'll use the body isolate to see if that did exactly what I wanted it to. Looks like it did. Now, to kind of show more trimming on dissimilar bodies in this area here, I'm going to go ahead and cut this item based on this here. And as I rotate, you'll be able to see that it's going to go ahead and cope this item based on that tube. Part of the reason I did this is I did want to show the extend function of the trim extend, since most of the time it looks like it's just cutting your material away. So with trim extend this time around, bodies to trim is this item, and I basically want to trim up to a face. If I specify this face, I'm saying the trimming boundary is this face up here. It's going to go ahead and extend that tube out to that surface there. And if I wanted a weld gap, I could specify that and set how much. Next, I want to demonstrate these pipes passing through this structural member here. Now, when I perform my trim extend and I specify this body to be trimmed, I want to trim it with these bodies, those three there. And I will not ask for a weld gap, nor will I allow extensions. The one thing I wanted to point out here as I isolate this body is the fact that it takes out the center. Now if I was doing an insert, combine, subtract, it would actually leave the center punch there. But as I rotate around, you'll be able to see that this tube is passing right through, and it is in fact cleaning that up quite nicely. So this is a little bit more intelligent than a combine subtract. It's going to go ahead and discard the center from that tube. Let me go ahead and close some of these. Oh yeah, and before I forget, I want to mention the interference detection. So with these trim options, I need to go ahead and generate a new assembly from this part, whichever template. And when I go to do my interference detection on the Evaluate tab, if I did a calculate up front, it's not going to find any interferences unless I invoke the include multi-body part interferences. Once I recalculate, it then finds all these interferences based on these structural members. Okay, so even though it's not available at the part mode, go ahead and drop your weldment into an assembly and take advantage of the interference detection utilizing the multi-body part interferences to check for interferences between your structural members. And with that, I'll go ahead and close this. Adding structural member profiles. When we first did our initial structural member, there were only 6 different types. And if you explore those 6 different types, you'll discover there's only about 3 to 5 different sizes per type. That doesn't give us very much to start with. So in order to expand that initial library, we have a couple different options. We can download libraries that SOLIDWORKS have made available to us. So underneath the design library for SOLIDWORKS content, you'll see a Weldments folder. Inside that Weldments folder, we'll find common standards such as ANSI, INCH, and ISO. The items that are located within these standards you may have seen underneath the toolbox, structural steel. In addition to these standards, we can also generate our own custom profiles. Any 2D sketch of a closed contour that you generate can be saved off as a cross-section for a structural member. Things to keep in mind when you're generating your own custom profiles is the origin of the sketch will become the default pierce point for that profile when we apply it to a path. Any additional points that you add to that profile sketch can be utilized as pierce points on your path sketch. Also, any file properties that you add to that part will become available later on as cut list properties. Now, in order to show you how to generate your own custom weldment profiles, I'm going to go ahead and open this file here. I have basically generated a 2D sketch and made one closed contour. On this closed contour, I also added in some additional points. Okay, these points I'll be able to utilize later on when I go to locate my profile. I'll be able to locate it on any point within the sketch, whether it's an end point at the end of a line or any sketch point that I've placed like this one here. These points could then represent the pierce point for this profile relative to the path sketch. Now, when going to save this, you're going to need to have a couple things in mind. First off, we're going to need a location to save these custom profiles. To set up a location for these custom profiles, you go into your Tools options, and under your File Locations, there's a listing for Weldment Profiles. Underneath the Weldment Profiles, you go ahead and add a new location for your custom profiles. Or you'll have to save your custom profiles in the default location. Once you've done that, you need to set up a couple of subfolders within your custom profiles location. I'm going to go ahead and bring up my Windows Explorer. Okay, so with my Windows Explorer, here's where I've got my custom profiles location. And underneath my profiles location, I'm going to need a standard folder and then a subfolder of type. Now, to kind of show you what these are used for, I'm going to go ahead and open another file here. And under my trim options, I'll go ahead and take a look at a structure member and bring back my Windows Explorer. Okay, so the first pick in the dialog box is my standard. Okay, under my custom profiles location, I've got a folder called standard. The second pull down is going to be your next subfolder of type. And then within the type folder will be your sizes. So as I click on the type folder here, you can see I've got 3 different sizes available. So to kind of show this, when I go to my standard, I'll pick standard. For my type, I'll pick type. And for my size, I'll pick one size. And then the next structural member is size number 2. The next size would be structural member profile number 3. So again, for Windows Explorer, I need to have a location for my profiles and a subfolder of standard. I named it standard so you could see how it correlates to the dialog. And then underneath the standard folder, the different types within that standard. And then the sizes will be the name of the files within that location. So to demonstrate how I would utilize this, I'll go ahead and go back to my item. To save this off as a structural member profile, I need to select the sketch, do File, Save As, and from Save As, I need to change my type to a library feature part. From the library feature part, I then need to go back to my location, which happens to be under my Weldments folder, where my custom profiles are located. Underneath my standard folder and my type folder, for my sizes, I'll just go ahead and leave this as 03 custom structural member size. I save that off. You'll notice that I get an L on the sketch here. That will tell me that this is now a library feature part. Also, if you look at the icon up top, it'll be a stack of library books. That also tells you that this was saved off correctly. Now when I go back over to my other part here and I go to modify my structural member, this will now be a size that's available. And as I click on that, there's my size. And as mentioned, when I go to locate the profile, any of these additional points that I've thrown in the sketch are now available as a pierce point for that path. Aside from making your own custom profiles, I did mention that there is some available for download from the design library underneath SOLIDWORKS content. For the Weldments folder, here are my standards. In order to download these, as I pause here, it says hold the control button down and then click to download the zip file. So as I hit control on the keyboard and I click on that item, it's now asking me where I want to download that to. As mentioned, the items that are contained within these can be found underneath the toolbox. As I add in my toolbox here, from the toolbox pull down, you'll find structural steel. And so for the ANSI inch, I've got all these cross sections. So once downloaded, I'll have all these cross sections and all these different sizes for these cross sections. And to kind of demonstrate those, I've already gone ahead and downloaded them. When I edit my feature, okay, ANSI inch, these were the default types. I only had about 6. From the download, okay, ANSI inch from download, you can see that I've got a lot more than 6. And then when I pick on one, I've got a bunch of different sizes. So you do not have to convert all the ones that are underneath the toolbox for structural steel. They're already available for you underneath the SOLIDWORKS downloads in the design library for SOLIDWORKS content and Weldments. And with that, we'll get on with the presentation. Fillet weld beads. The reason we'd want to include fillet beads onto our weldment is the fact that they are taken into account for mass property calculations. But at the same time, they will not be included in the cut list. So if I had some structural members that I was adding to my frame, either for shipping or installation purposes, that do not actually remain with the structure after the installation, I could set those structural members to be weld beads so that way they would not be included in the cut list. To do this, you simply right-click on the structural member in the graphics display and toggle the Make Weld Bead, or to turn it back into a structural member, right-click Make Non-Weld Bead. And with that, I'll show this. Okay, so for my fillet weld bead, I'll go to my Weldments tab and specify fillet bead. And for the arrow side callout, I'll grab face set number 1 and face set number 2. And here I can see the preview is a full length weld bead of 1/8 inch. If I requested that to be an intermittent weld, I could specify how long the bead is and the pitch or the spacing. So if I space that out, maybe I have a 1/4 inch bead length with a pitch of 1/2 inch. So I hit OK, you'll notice that SOLIDWORKS gives me the call out. If I wanted to do an other side down here, I simply specify my face set number 1 and 2. And here I've also got an intermittent set for the other side. I could ask for a full length on this side. And my call out adjusts accordingly. If I wanted a staggered weld bead, I could ask for that as well. Okay, and my call out is appropriate for that. If I take a look at my cut list, you can see I've got 43 items. I may want to update this so I can see how many structural members I actually have. And I can see I've actually got 2 cut list items, and the rest are all fillet beads. If I did not want this included in my cut list, I could right click on it and specify Make Weld Bead. Next time I update my cut list through Update, you'll notice I only have 1 cut list item. To convert this back to a cut list item, I simply right click on it and specify Make Non-Weld Bead. Next time I update the cut list, now I've got 2 items again. So again, all these weld beads will be ignored when I go to generate my cut list. I will only have 2 items in the cut list. And with that, we'll get back to the presentation. For adding non-structure member parts to your weldment, we can insert parts into this weldment just like an assembly. And again, this would be for existing or purchased parts. In this example here, I've got weld tabs that I've dropped in. Additionally, if I wanted to add plates, all that's required of me is to generate a sketch and a closed contour and go to extrude it. While I'm in the Weldments environment, the merge results checkbox will be unchecked. And we'll go ahead and show this. For adding non-structural members to my part, okay, off-the-shelf parts, from the insert pull down I can specify insert part, and from here I can browse for additional parts. Maybe I want to drop in that tab there. Okay, when inserting my part, SOLIDWORKS gives me the ability to transfer all these items from the part. I want to make sure that my locate part launch move dialog is checked. When I click to position it, SOLIDWORKS is going to allow me to locate it either relative to coordinates or with constraints. You'll notice that these are just like my mates for an assembly. Now to position this, I'm going to go ahead and specify my location, maybe the top of that face with using select other, that bottom surface there. Now I need to hit add, not OK. If I hit OK, it exits the command. So I'm just going to go ahead and click on my next selection set. And because it's going the wrong direction, I need to flip the mate alignment. And I actually want a distance in there of 2 inches. And then I need to locate it. And I'm going to use my planes for mating. That should just about do it. If I wanted this weld tab over there, I could always mirror it. When mirroring structural members and or purchased parts that are in your weldment, the type of mirror you want to utilize is going to be the body mirror. So I'm going to go ahead and mirror across the right plane, and the bodies to mirror is going to be that tab there. And here, if I look at my cut list and I update it, you'll see that those tabs are placed inside the same cut list item folder. Additionally, if I wanted other parts, insert part, and then from here I can click on my next tab and bring that in just the same way, and utilizing my locate part and maybe my select other. Okay, when using select other, you can ignore that dialog and instead take a look at the cursor. The right click is a pair of eyeglasses, and that hides faces out of the way. That allows me to peel apart my model till I get to the face I want. That's the face I needed, so I'll go ahead and add a concentric there. And then if I wanted to specify distance off the end here, I could do that. Maybe 3 inches off the end there. Add that, and that one's located as well. And then to show that one more time, insert part, grab my last tab, make sure launch move dialog is on, and then position it, and through select other, add another constraint, maybe the bottom face here or plane with that surface there. Give myself a distance, flip direction if you need to. Maybe I want 1.5 inches off of that front face, and then finally a coincident to center it. And there are my weld tabs, all purchased items. And I'll go ahead and hide the planes here. Additionally, if I wanted another plate on here, all it's required is I make a new sketch. Maybe I want to add a circular plate on the end here. Go ahead and open a sketch on that surface. Draw my circle out like that. And then go to extrude it. You'll notice that the merge results checkbox is unchecked. specify my thickness, and now my cut list now contains 7 items. That one there, and then my different weld tabs, as well as my structural members. One last tip on non-structural members. I can still generate a weldment without using structural members. I can go ahead and throw an extrude and draw up a plate. And when I invoke the weldment feature, when I go to apply my secondary extrude, you'll notice that the merge results checkbox will be unchecked. So here you'll notice it's cleared, and when I do that you'll see that I've got 2 different plates. I could force that merge results checkbox to be enabled, and that would simply merge these 2 volumes here. Okay, but again, I can generate weldment structures without structural members. And of course I could still throw in my fillet bead. And with that, we'll get back to the slideshow. End caps and gussets. We have the ability to apply end caps to open structural members. We also have the ability to apply gussets between intersecting structural members so long as they have planar faces to support the gusset. One of the new things with regard to gussets in SOLIDWORKS 2009 is the fact that we can now apply a chamfer to the back side of the gusset to allow for clearance for fillet weld beads. And with that, we'll take a look at this in SOLIDWORKS. For end caps and gussets, I'll go ahead and apply an end cap to the open end on this structural member. Then I'll look straight down on this to show the options. First off, I need to decide how large to make the end cap. I could either use an offset distance. If I knew my fillet bead was going to be 1/8 inch, this 1/8 inch is being calculated from the outside edge here. Or I could specify a thickness ratio. Thickness ratio of 0.5 is basically going to calculate the wall thickness on this structural member and then divide it in half, and that's where it'll put my end cap. A thickness ratio of 0 is going to force the end cap to be as large as my initial structural member. I can also request the corners to be chamfered. I can specify how large the chamfer should be. So if I wanted 0.75, I could do that. One of the new things in SOLIDWORKS 2009, as I take a look at the front view for this, my initial sketch was 24 inches. In other words, that's the outside dimensions of my weldment. Currently, the end cap is sticking out over my 24 inches, which means I either need to go in and adjust my initial sketch, or I would need to apply a manual cut to the end of the structural member prior to adding my end cap. Well, new to SOLIDWORKS 2009, for that end cap feature, we now have the ability to specify what direction the thickness is being applied. If I specify it inward, it'll push the cap to the inside and automatically chop off that structural member. So now when I take a look at this, the 24 inches is to the outside of that end cap. To apply a gusset, simply click on the supporting faces and choose your type, whether it's polygonal or triangular. If I look straight down on this as well and zoom in, I can take a look at the positioning for this, the location. Currently it's set to the start point. If I click this, it'll throw it to the end, and this would be in the middle. Now, I said this is set to the middle, but my material thickness is set to the outer side. If I set it to the middle or both sides, it's going to go ahead and populate equally. If I went back to the start, you'll notice it's going to apply to the inner side. If I did both sides, it's going to basically put the middle of my gusset to the starting point of my location. So to have it centered, I want to use midpoint and both sides. If I want it to the outside, I would specify outer side. If I want it to the inside, I want to make sure that's set to the inner side. Now, if that wasn't enough, just turn on the offset and then specify how much to offset the gusset from. So in this case, I'm offset 1/4 inch from the midpoint based on the exact middle of my gusset. Again, I could specify where that offset is coming from. Here it'd be from the inner side. Although a little strange on how to position this, this will give you exactly what you need. Now as I go to apply a fillet bead, I'll put a fillet between these here. You'll see that my fillet bead is in fact interfering with my gusset. If I wanted to allow a clearance in there, I would need to add a chamfer of some sort to the gusset. So in 08 I would go back in and add a chamfer manually to the gusset. But now for SOLIDWORKS 2009 we have the ability to, right inside the gusset feature, request a chamfer on the back side. When I turn it on, I specify how big, and so now my gusset has been given a chamfer on the back side. We have this also for the polygonal gusset. Same scenario. Specify what the supporting faces are, the thickness, and the location. And of course, how large that chamfer on the back side is. If I wanted to make my own custom end cap, maybe up top here, I could open a sketch and convert the inside edge and then go ahead and extrude that inward. So this is similar to making a plate earlier. Again, you'll notice that the merge results is automatically unchecked. So when I hit OK, SOLIDWORKS is going to go ahead and throw that plate in there. Now to throw a fillet bead in there, I would need a chamfer. So I'll go ahead and manually chamfer this. At 1/8 inch. And then I'll go ahead and throw in my fillet bead. And here you can see a custom end cap with the fillet bead. Again, just to talk about adding plates. And with that, we'll continue on with the presentation. Sub-weldment and post-machining operations. A sub-weldment is a group of structural members and or plates that are welded together prior to being added to the top-level weldment. For post-machining operations, there is an as-machined configuration automatically added once we enter into the weldment environment. We can take advantage of the feature scope underneath our machining cut features to specify which structural members and or plates the feature is being applied to. One note on this: you want to make sure that those cut features are being suppressed in the child or as welded configuration. For my sub-weldment and post-machining operations, first thing I'll talk about here is making the sub-weldment. What I'm going to want to do is identify what I want to have in my sub-weldment. As I take a look at my table here, it might make more sense to generate this hexagonal structure with the cross member in the middle first. In order to separate it out into a sub-weldment, I need to find the structural members in the cut list folder, and from there I'm going to right click on a structural member and specify create sub-weldment. That generates another folder, and then I simply want to drag and drop all these other structural members that I want to be a part of that sub-weldment feature. Additionally, I want that cross member, as well as the fillet beads that go with it. So now this should be my sub-weldment structure. To document this accurately, I may want to drop this into its own part. So to do that, simply right click on your cut list item and specify insert in a new part. The default template that it uses for this new part can be specified under Tools options for default templates. These are the templates that will be used for operations such as file import or mirror part when SOLIDWORKS does not ask you which part template to utilize. Over here you'll notice I have my cut list. I can then update it so it groups like sizes together. Now you'll notice that the weld beads did not stay separate, so I'm going to need to tell SOLIDWORKS that those were weld beads. So I'll go ahead and use my magnifying glass, new in SOLIDWORKS 2009. It's the G button on the keyboard, and basically right click on this fillet bead and tell SOLIDWORKS make weld bead. And I'll want to do the same thing over here, except I need to dig for it, so I'll use select other and hide faces out of the way until I find the one that I want, and then use that to make weld bead. Then once I update the cut list, you'll notice that both of my fillet beads have been pulled out of the cut list. The other item I wanted to talk about was post-machining operations. For this, I'm going to go ahead and view on the top, and I'm going to give myself a wireframe, because what I want to do is basically drop in a hole everywhere there is a tapped hole in the frame below the tabletop. So I'll go ahead and drop in my hole wizard, and to make this obvious, I'll generate a fairly large hole, so 5/8, and I'm going to make sure that this is through all. And for my positions, again, I'll use my magnifying glass, the G button on the keyboard. That will allow me to pick the center of these holes without having to zoom in. So you can see that this magnifying glass does have its advantages. Makes it a little bit quicker without having to zoom in and then back out and then back in. Especially on presentations like this, I'm able to keep my screen zoomed out, yet still pick what I need, and when I'm done I just hit G again, and that gets rid of the tool. Now if I select OK, it's going to cut through all these items, and I will go ahead and do that. That way I can talk about the feature scope. In fact, I'll give myself a shaded view. Now as I zoom in here, you can see that my 5/8 hole went through all the structural members. However, when I edit my hole wizard, I want to talk about the feature scope. The items that are located in the feature scope will be all of the members or multi-bodies, solid bodies that will be cut by this feature. I'll go ahead and remove those and tell SOLIDWORKS I only want this tabletop here to be impacted by my cut. As I hit OK, that is the only plate that has received the cut now. The last thing I need to do here is make sure that my as welded configuration does not have that cut present. Looks like currently it does. My as machined is going to have that cut there. My as welded should have it suppressed. So I want to make sure that that is suppressed in my as welded configuration. And as I go back to my as machined, those holes should be there. And with that, we'll get back into the slideshow. Cut list and exploded weldments. A cut list is like a bill of material for my inseparable assembly. However, unlike an assembly, I do not have multiple part files, each containing their own file properties. Instead, I've got a single part file with multiple bodies. And in order to give each solid body their own properties, we go to the cut list item folders. And underneath those cut list folders, we can assign properties to the individual bodies. When generating your own custom profiles, any file properties that exist at that library feature part will become cut list properties for any structural members utilizing that custom profile. Additionally, default properties can be added to the Weldment properties.txt, and you can find out where it's located from the Tools, Options, File Locations, and in the pull-down, Weldment Properties. Then when I go to assign my properties to my cut list items, those items will be available from the pull-down. Finally, for an exploded weldment view, here's one of the tips in the webcast. Although this is not an out-of-the-box function within a multi-body part, we can go ahead and accomplish this utilizing the Move Copy Bodies command. And with that, I'll show you how. To show the cut list functionality, I'll use this file here. One of the tips that should come out of this webcast is the fact that weldments should not be reserved for steel-only structures, but in fact implemented in any modular design process. Here you'll see that I have an oak end table, and if I was going out to present this to a potential customer, they might take a look at this and say, yeah, you know, this table is way too simple. Well, if I used weldments to begin with, I can swap out the cross-section of the pieces being used. So for example, if I was going to change out the top for the table, I could specify a different cross-section. Maybe swap out the legs. And finally swap out the skirt. And within a few clicks, I have a totally new table to show my client. And I can go back and forth and swap out the different profiles until I find one that they like. From here, I'll go ahead and show the cut list. Now, underneath the cut list item, you'll notice that I have 4 different cut list items. To show the properties for each one, you simply right-click on the folder and go into the cut list properties. Now, by default, SOLIDWORKS is going to throw in a length for each cut list item. This cut list length will be calculated based on the initial path sketch and based on the corner option. In this case, I have a miter corner, so I have angle 1 and 2, both at 45 degrees. My initial cross-section sketch, or profile sketch, that is saved off as my library feature part, had a file property of description, and it had already been filled out as border. If I wanted to add an additional cut list property, I can type whatever I like in here, or from the pull down I can access previously saved properties. For example, I'm going to go ahead and use weight and link it to the mass. Now, the items that are available from the pull down come from that Weldment properties.txt file. That Weldment properties.txt file can be pointed at through the Tools options for File Locations under Weldment Property File. As I link this to the weight, I did want to point one thing out. The mass is only taking a look at one of those structural members within that group. So it's going to give me a per unit weight. Now, to kind of show this in the drawing, I'll open the drawing. And within the drawing here, you can see I've got a description and a length for each structural member. The base was not a structural member, so it does not have a length. Now, I did add weight to the border, so to bring that in, I'm going to go ahead and add a cut list property. To do that, you right-click on a column and insert a column to the right. And then from that column there, I can specify a cut list item. And from the pull down, because weight was applied at least one of the structural members, it'll be available. And in fact, you'll notice that I had already set weight for all the other cut list items. The second thing I had mentioned was an exploded weldment. Now, to do this, you need to go back to the initial part. And within this weldment, to set it up correctly, you'd want to go into your configurations and generate an exploded config. Once you have an explode config figured out, the next tool you want to use is your move copy bodies. With that, I can specify which items to move, maybe those 4 there, and then what direction to move them in. Now, this might seem a little clunky, but if you really need an exploded weldment view, it's a great tip in order to get the required drawing that you need. As you can see, I already have some suppressed move copy bodies in my tree, so I'll go ahead and delete this one and instead switch over to my exploded view. So my explode configuration, and there's my exploded view. Now, to do the explode line sketch, I drop in a 3D sketch, as you see I did here. And then you can go ahead and show your exploded line tools through the exploded sketch. And you can use the route line tool just like we do in assemblies. Once I've got all that figured out, then I can go to my drawing and add in another view. In fact, I made a custom view called Explode. And there's my exploded weldment view. And with that, we'll get back to the slideshow. Weldment Drawings. We can add balloons to our weldment structure. The callout shall match the cut list table. Relative views. We can add individual views of specific structural members to call out further detail. New to SOLIDWORKS 2009, we have the ability to show our cut list in an assembly bill of materials. In order to do this, for the bill of material type, we need to use the indented assemblies and then check the option Detailed Cut List. Now in 09, we can accurately represent weldment assemblies on our drawing. So to show weldment drawings, first up I'm going to balloon it. So on the annotations toolbar you'll find balloons and auto balloons. With the balloon tool you just simply click on the structural member and place the balloon. As mentioned, these will all match what's in your cut list. If I needed to detail out a specific structural member, I can drop in what's known as a relative to model view. And here I specify which bodies I want to bring in, maybe that one there, and tell it what the view orientation is going to be. Maybe as I zoom in here, that's going to be the front orientation, and this other face is going to be the bottom orientation. Now as I go to position it, there's my drawing view. From here I could even do a projected view. So now I can detail out that structural member. And finally on the next page here, this is an assembly to kind of show that. I basically have my weldment, the base end table, and I've got a chessboard. So here I've got my bill of materials. In order to show the cut list in the bill of material, I simply click on the bill and specify indented. And now to SOLIDWORKS 2009 gives me the option for detailed cut list. Once I drop that in, I can see within the end table all the structural members. And if I want detailed numbering on that, I can request detailed numbering. And if I want to show the length, I can go ahead and drop in a column to the right and specify the length property. And as before, I can go ahead and balloon that. So now, as I mentioned, we can accurately represent weldment assemblies in our assembly drawings. With that, we'll finish out the presentation. Thanks again for joining me on yet another productivity webcast brought to you by Digital Dimensions. I am your host, Joseph Richter. To find this and other webcasts, please visit our archive site. It's going to be webcasts.ddicad.com.